transactional messaging APIs or like regular promotional messagings. There is a limit.
And so there definitely is. The thing is like that limit is also complicated because there are limits. I mean, this might be the Marketing Cloud limit. If we're talking about platform events, there are limits to how many events can be delivered, and it's based on allocations and SKUs you have. There's also limits on how many you can publish. And it's like those limits are very different from each other, and they scale together, but they scale in different ways. And I have like a whole presentation on that. It's like too hard to just have a little anecdote to explain it. Yeah. So if we can just hold on for a minute, once we get to my presentation, we can walk through that.
Okay. Actually, it is like overall limits, not specifically for Marketing Cloud. Any API call in the Salesforce, like, based on the license, number of licenses per license, it is 50,000.
Yep, we'll definitely talk about it. It's not actually 50,000, but we can talk about it.
Right. Thank you.
I guess I'm next. So real quick. So Tyson, you mentioned about CDC and platform events. So whenever I'm thinking about streaming API, I think of CDC, platform events, probably generic events, maybe push topics. Where does PubSub API come into this landscape? Is it going to replace streaming API, or it already has? Could you shed some light on that?
Great question. So PubSub API, the events, I got a slide somewhere in here. So the events that we support with PubSub API are Kafka-backed events. So that's high volume platform events, change data capture, and real-time event monitoring. So no support for push topics or generic streaming. That's all backed by our legacy Oracle-backed systems. So that's separate from PubSub API. To kind of answer your question about like, hey, what does this mean for Comment D and the streaming API? The answer is like nothing right now. We don't have any plans around, like how this impacts Comment D. What I will say is that PubSub API, kind of going back, kind of the reason why we started building this was that we were trying to basically scale how much eventing Salesforce itself can do. So PubSub API exists outside of Salesforce's core app and like in our own infrastructure. So essentially, like this is where we're targeting all of our API development. Is really like how do we kind of leverage this horizontal scalability that we have in the stack to address the needs of core, the needs of our other Salesforce clouds, and really kind of have a more centralized place that we can serve this eventing from. So I think the take home is if you're happy with your streaming API and Comment D integration, great. Like keep using it. Like it's not an issue. If some of these new features that I'll talk about in a second for PubSub API are exciting and you're interested in kind of exploring that, I would encourage you to do so.
Gotcha. Thank you so much. I mean, I'm happy. I would like to be happier for sure. So
yeah, sure, exactly.
No more. Thank you.
So one thing I'll just add, most common thing that I hear is processing efficiency. That's usually one of those biggest triggers. So we talk about limits right now. So that's usually one of those symptoms or one of those clues why I personally would go towards a PubSub API as opposed to what we've known before, right? So that's one of those clues that we always look at.
Yeah,
I see.
I think some of the other big differentiators when you're considering, when you're trying to set up a new integration, are also going to be really like, hey, well, what's the difference when I'm working with these two? One of them is going to be that PubSub API uses gRPC. So part of that is thinking about, hey, do I want to mess around with an API format that I may or may not be familiar with, right? So that's one decision that you can kind of think through. Feature-wise, the other pieces that you get with PubSub API is you can publish and subscribe within the same API. So you're not writing two separate clients to do this. You can, interact with all of these operations in one client through one API. The other that is potentially a little confusing, but I'll try and unpack it, is when you're publishing into Salesforce with PubSub API, you get a real-time publish acknowledgement. So when you publish an event, you get a response from PubSub API that says, hey, that publish was successful, or hey, that publish failed. And the idea is that, hey, if we had some sort of connectivity issue, we're unable to successfully write that event to our Kafka, we're telling you that in the moment so you can retry. And the reason why that's exciting is that you couldn't do that before. So before, when you were working with the REST API, you'd get a response saying that, hey, we got your request, but that didn't mean that it was actually committed to Kafka. So now we can give you basically a real-time receipt of like, hey, your event publish succeeded. You can move on. Does that make sense to everybody? See a little.
Yep, I think so. Sorry, I'm trying to stay off mute, keep the extra noise. But
no, perfect. So that's one thing. The other is the subscription flow control that I mentioned before, where with streaming API, it was streaming. So as those events were published, they were immediately pushed to your client, and that's how we would get into this scenario where clients could just be flooded with events, and sometimes. We'd see a few different things. Either you'd have to ramp up your processing, which wasn't always easy, right? Like not everybody had like a way to elastically expand how they're going to consume all these events with their clients. Sometimes people would run out of buffer for kind of the same reason, right? They might not have been able to just elastically expand how much buffer that they could hold these events in before they actually processed them. Or we'd see another scenario where the client would just get overwhelmed, it'd go offline, and then it would struggle to kind of pick back up in the stream. So what we did is we moved towards a pull-based subscription. So the client requests events, and then we give the client however many events that it requested. So we're able to kind of switch that paradigm up a little bit, so you can make sure that the client doesn't get overwhelmed. And then the last big feature is kind of baked into gRPC itself, which we can unpack a little bit more, which is gRPC has support for 11 different languages, which is great, right? It's nice to be able to have a little bit more diversity in clients that you can work with. Typically, I saw a lot of folks working with Java that were building Comet D clients. Every once in a while, I'd see Node, but broadly, it's just nice that we can help people build clients in the languages that they want. So any questions on this stuff? I see that Rao and JJ have hands up. We've been ignoring them. What can we discuss?
I actually have a question specifically on that, right? So with subscribe, and thank you guys very much for tonight's session. But with subscribers being able to throttle, essentially, right, how many events they want to receive at a time, and the replay of events being limited. Isn't there some sort of is there some sort of lifespan condition that needs to be worried about there? Like if I'm publishing 100,000 events, but I have a subscriber that's receiving 10 at a time, like is that eventually gonna run out? I don't know what that
100%, yeah. So this is part of the danger of flow control, right? Is that you can throttle your consumer so they don't get overwhelmed. But if your publisher is consistently publishing faster than your consumer is consuming, they're going to start falling behind in the stream, and eventually they'll fall out because we only store the events for 72 hours. 72 hours. Okay, so,
so that is a concern that we still need to worry about. This doesn't like take that. Okay. Right.
Yeah, it is, but I'd say that an easy way to address it would be, for the events that you're getting, you're going to be able to see, hey, what was the time that this event was created, and if that starts slipping farther and farther behind, that's a good signal to say, oh, hey, I gotta check out, like, what's going on here.
Yeah, makes sense. And then so if I can, so for one other question on inbound events, as we're receiving those, very awesome with Pub Sub API, not hitting our API limits, but triggers that we put against those platform events, are we going to be allowed to make our own web service callouts on those triggers?
So Yeah, go for it, Peter.
Yeah, so what you're saying is you can have a trigger or a flow subscribe to that, and then you'd say once it receives that, you want to do a call out. Is that the question?
Correct. Yeah.
So there is a trick there, because inside it's kind of considered a DML context. So you can't actually do a call out from that DML context. So you'd have to do something where it would go to another context like at future or Qubel to actually do the call out.
Got it.
Do you know if that's going to change? Forward-looking statement, quote unquote.
I don't see it because it's like such a deep paradigm in Salesforce, right? I don't see that changing. And one of the things to really consider with this is also, actually, you know what? I'm going to put a pin in this one because I cover this in my my content.
We're just teasing Peter's.
I'm going to pause.
Peter's gonna, like actually address everyone's real
just
questions.
like punchlining
Well,
my
at
whole
this
thing.
rate, we're not going to finish this whole conversation today. So this is great.
And for context too, I'm leaving a little bit earlier than Peter is, so this is why I'm going first instead of going after Peter. So thanks for bearing with us.
Thank you again for the time. This is fantastic.
Oh, it's my pleasure. I'm delighted to be here. Cool. So that was JJ's question. Rohan, I see you've got one too.
Hey, my name is Rohan. I'm working for Workday, but couple of years back when I was working for Vistra Energy in Dallas, we were working on Marketing Cloud, and we were trying to do this with we were trying to pass on the event with middleware, but middleware has a timeout. So how we can solve this problem? I mean, in better way, because middleware will stop at some time, maybe a couple of seconds before or after. So how we resolve this issue with working with events?
So that one might be a little left of field, and given the schedule we're going to try and keep, can we Ron, can we address that at the end? Is that okay?
Sure, no problem. Yeah.
Tyson, Peter, is that all right? I feel like that was yeah, thank you. Okay.
Frankly, Peter will have a better advisory than I can.
Because I get punched in the face all the time. I'll be able to answer it.
All true speakers have that problem.
So that's kind of the highlight of like what's actually new about PubSub API and like how does it differentiate from the other ways that you could work with events from an external system. I've got a slide here to kind of unpack gRPC. gRPC is a API format that was open sourced from Google. So it's something that we've used internally at Salesforce for microservice architecture for a few years now. And it's really helpful for dealing with distributed systems. We've also enjoyed working with it within Salesforce, just with some of the performance benefits that we get over having a REST API. And then the last thing that we were really thinking about when we were trying to figure out how are we going to make it easier to work with eventing was we were really intrigued with this capability of being able to do bidirectional streaming, and having this ability to say, hey, you're publishing events, but we're streaming back acknowledgements to you. So you can do that a little bit more efficiently. And finally, the other thing is that we've gotten mixed reviews about Comment D and how much people like working with it. So we really wanted to offer another alternative to folks that are not Comment D fans, frankly. So that's gRPC. One of the other things that comes into play when working with PubSub API is Avro. If you're not familiar with it, Avro is a library that you can use to serialize and deserialize events. So we've got them here. We've got links to all the different Avro libraries that you can use with the different gRPC languages. So that's another way to kind of get everything up and running. And then kind of the point that I'm trying to get into in this slide is, I talked a little bit about how this is kind of leveraging our underlying Kafka capabilities at Salesforce and sort of the events that are all on our Kafka event bus. But really what I'm trying to drive home here is that like the events themselves are not changing. So if you already have events in place with Apex or Flow, that's great. Like you can keep working with those with PubSub API. Like the only thing that changes with PubSub API is this is a new way to integrate Salesforce with an external system. So that's really the main thing that's changing. So if you're not working on a system integration project, it's not relevant and you don't have to worry about it. If you are trying to connect Salesforce to something outside, then it's a good option to consider. One other little wrinkle that I'll throw in here is that also includes if you're working with Lightning Web Components, right? So PubSub API is really just system integration. It's not going to support building a Lightning Web Component that's going to subscribe to it. So that's all staying as is.
Yeah, there's no JavaScript gRPC client yet, is there? Like client side. Ooh, Peter's nodding his head that there is.
Yeah, somebody's put one together.
Well, like not client, not like browser based, but there's no,
yeah.
which is JavaScript. Yeah.
Gotcha. Yeah, Comet D and having to. Yeah, I stopped learning Comet D when I had to install something on my PC. If it's not JavaScript based, I don't usually deal with it. So I keep waiting. There's got to be a listener at some point, but not today.
Yeah. The other thing that I'll be pretty upfront about is that one of the challenges that we've had with folks that are trying to get Lightning Web Components to subscribe to events is there's been a limitation on how many concurrent subscribers you can have, which is 2,000. So you could have, if you build a Lightning Web Component that's listening to events, you only have 2,000 of those out in production before you start running into limits. So that's fine if you've got, like a small shop and you're not trying to serve up, a Lightning Web Component to 2001 people that are looking at it. But there are ways to kind of scale that and handle the fan out of how you can serve events up to Lightning Web Components without using this direct Comet D method. Is there anything, Peter? Is there anything you want to add to that, or is I know this comes up frequently, and it's a pain point for customers that are really trying to drive UIs. Yeah,
like that's actually an anti-pattern. So
Yeah.
It's something called EMP API, and that's the Aura component that you use. It's an anti-pattern because there are two things: the subscriber limit. So some of the orgs and the customers I work with have over 100,000 users in an org. It won't work. Like everybody logs in the morning, and like 2001st person, it pops. Yeah. The second thing is, imagine like when you're publishing this and then you're going to deliver it, you're literally multiplying those deliveries by 2,000 every time you send it out. Exactly. And like that's one of the allocations on some of you pay for. So it's really an anti-pattern. It's like really cost prohibitive to do it that way. And there are much better patterns, which as a teaser, I'm covering in my section.
Okay.
Beautiful.
I was about to follow up with about 800 questions. I will hold them.
Even better.
2,000 is not a number I'm used to dealing with in Kafka world.
No,
so let's address okay.
And the backstory for there is really just that like we have been building this with the intention of it being about system integration, right? So the scenario where somebody has like 2,000 external systems that need to listen to Salesforce, like that's the least of your problems. You've got other architectural challenges to worry about. So cool. So we'll keep moving. The other thing that I wanted to get on folks' radar is that if anybody's using MuleSoft, there is a MuleSoft connector for PubSub API. So that gets you out of having to build a client. That's something that is GA today, so you can work with that right now. So we've been really excited for kind of what that means for folks to be able to, take advantage of this without having to go through the dev cycle of getting, a client up and running. Kind of shifting the gears for like what's next with all of this. So we just GA'd PubSub API in June. June 30th is when we went GA. So kind of up next, we're sort of in this mode of doing a lot of the post GA service ownership items, kind of like trying to clear the deck so the team is really ready to kind of dive into a lot of new features. And this means that right now we're having a lot of conversations with customers about what would make your life easier to build event-driven integrations with Salesforce, and how can we make PubSub API, fit into your architecture better. The pieces that we're looking at most seriously and are getting the most attention right now and the biggest response is around subscription management, and making it easier to manage, easier to build clients, easier to kind of manage multiple clients. And in particular, what that looks like is, tracking the last processed or last delivered replay ID for a client. So if they come up online, they're consuming events and there's some sort of interruption in that subscription, it's easier for them to come back online and resume where they left off. Right now, you can do that today, but some of the logic that's entailed in building that is something that has to be done client side, and we want to make that easier and just make it a part of the API that you don't have to worry about. The other thing is trying to figure out, hey, how do we help customers that want to have multiple clients that are consuming in parallel? How do we kind of bring like a Kafka consumer group like experience to PubSub API so you can do a lot more efficient parallel processing? That's not something that you have to track on your side as well as a client. And then the last thing is kind of around, and this is sort of like a broad topic for eventing in general, is really trying to help customers get a better understanding of what their usage looks like. And in particular, some of the feedback that I've gotten that I thought was really interesting was if we made it easier to kind of get like a real-time insight into where you're at against your eventing entitlements as you're consuming them. So say if you're getting close to hitting your entitlement, you can have a client that's able to make some decisions and say, hey, I don't care about contact change events. I just need this right now. And you can kind of have a little bit more flexibility in how you churn through everything. Yeah, so those are some of the big things. At this point, I'm also excited to kind of hear what's next as people play with this and get their arms around it. So I'm like, we're actively trying to get opinions from customers about what we can do to make this easier to work with. So if anybody's been working with PubSub API, please reach out to me and tell me what you think. Tell me what we can do better. So I think that is about it. This is all old Dreamforce stuff. So these sessions are in the past. This slide is still helpful though, and we can share this deck with you guys afterwards. But essentially, I'm trying to get everybody to use this QR code and this link here to head to a Quip doc that I put together that's got a bunch of documentation on links to our developer docs, our GitHub. We've got a cool demo video that Developer Relations put together that shows you, I think it was a Node client that Philippe made. So yeah, we got some great stuff for you to check out. Oh, and the last one is we put together this Lucid chart template that you can download if you're using the Salesforce Architects Lucid charts. So that's pretty much it, I think. Yeah.
Great, thank you, Tyson. Outstanding. Anybody have questions for what Tyson went over before we release him to run? No. Good stuff.
And
Okay.
then I think we'll switch over to Pete's section. That's cool. And then Tyson, you had to leave, yeah?
I should get going. But yeah, I'd encourage you guys, if there's anything else that I can help you with, any feedback you have, please reach out. And I'll make sure to share contact information, I guess, with Abigail and Paul, so you guys can reach out. You can always get a hold of me on LinkedIn or Twitter, and then also, really bring all of the hard questions to Peter, because he's been in the trenches with all of this.
Outstanding.
He gets punched with events every day.
Thank you.
No, but honestly, like Peter's like really seen a lot of implementations and has a lot of good ideas of how you can work this into your architecture in like a very pragmatic way. So it's awesome that he's here today and can really help us get a better idea of what does it mean to actually put a lot of this into production.
We really appreciate all of you taking the time to come talk to us. So this is Salesforce going off the chain as far as little apps versus being able to do these fully enterprise scale applications with functions and the event bus. It's, yeah, I know, I'm really excited. This is no longer just hobby applications, even as big as they get. This is geometric progression. So thank you again, Tyson.
Yeah, my pleasure. Thanks so much, everybody. Have a great evening. See ya.
Thanks. Awesome, Pete. Yeah, so you're presenter. Awesome.
I have
Thank you.
everything I need, I think. Can everybody see this?
Yep.
All right, perfect. So some of this has been covered. And so I'm going to be like jumping around slides a little bit, but in general, the things that I want to talk about are like kind of like expanding a little bit, going not only over high volume platform events, which we can just call platform events because there's really no other kind anymore. So platform events, change data capture and streaming API, because these are like the 3 ways that you can actually get streaming data out of Salesforce. So we're going to start there. And I'm going to talk through some of the concepts. Feel free to like raise your hand if you have questions right away. It's fine to like interrupt me, just like Tyson's presentation. But I'm going to go down a little bit more into the nuts and bolts, like what you should consider like while you're building these things out. There are some caveats. There are some interesting things behind how the allocation works. So that's kind of like what I'm going to try to walk through, if that makes sense. No vaccine cloud. So he kind of covered this, so we don't really have to talk about the overview. The big thing here is we went over this. There are the core APIs and there's pub sub API. You can really accomplish the same things in general with both of them. The new stuff with pub sub API, he covered in depth. When we talk about using Comet D and our regular APIs, it's a little bit more old school. You're using everything's JSON. It's all kind of like familiar to everybody, except for when you start talking about Comet D. And Comet D, there's a whole history on why we chose Comet D. It has to do with like the fact that it's a long polling architecture, which is for a long time, browsers didn't cover WebSockets, for example. There was no coverage for them. So we had to use something that all browsers could use. And it's how our notification bell works is through Comet D. So there's a reason why we chose it. And then as the years go by, it's like, well, should we change it? It's a lot of work to change it, right? We've already built this, it's not broken. And then eventually we're like, yeah, it's time. Let's use gRPC. It's something we're using internally, and we can give it to our customers. So that's sort of, I don't know if the history stuff is interesting. Let me know if you just don't care, and I won't cover it, but to me, it's interesting, the history of it.
Speaking of history, so how many in here and online have had to work with a vaccine management system? Okay, I figured I wasn't the only one. Yeah, we had to rewrite a vaccine management system because communities couldn't handle the number of signups that were going on, and we had to push stuff out and create a Heroku app. It was not a pleasant time in my life.
Yeah, that was actually basically my whole job when everything went down. It was like trying to come up with like some sort of architecture internally. We had like a very small team of people in Salesforce to figure out how we could scale, because the scale was insane. 75,000 a minute, that was the thing. We had some that were peaking at like 100,000 a second. So anyway, vaccine management is fun. I'm glad we don't have to worry about that too much anymore.
Yeah, no, I'm still a little scarred from that. Sorry about that.
Exactly.
Hey,
Exactly.
I have a question or a comment. You remember like when Obamacare came into picture, people were trying to register, those applications did not work several months. Probably this, your gRPC or your PubSub, could have helped them a lot. I don't know whether it was there or not, the technology. This I'm talking about like 7-8 years ago when actual Obamacare came into picture. People started writing, putting that application. The whole application was not working at all for several months.
Yeah. And it's interesting because like platform events have changed over time too. So when it was first announced and we first had platform events, I don't know if anybody has been around to like deal with this. I look young, but I'm really not that young. I've been around doing Salesforce for a long time. Like it started being backed by the Oracle database, and the limits were kind of crazy. It was like 4,000 events per day, which is like kind of a joke when you get into the world of eventing. Like 4,000 a day is like, I think it's just for demos. I don't think it actually works in the real world. And there were huge problems with it. Then we had to like completely change the architecture underneath. And I think they did it to see if people were actually interested in using us. And it created some cases in Salesforce. Then we completely changed everything under the covers to Kafka and built, we have like all these internal names for the different structures that we built, and one's Aqueduct. But it was like a whole architecture to be able to handle this and handle like individual subscriptions and who needs what when. And one of the interesting things with platform events, it's going to come up, so I'll say it now, is that when you're a subscriber to platform events, and that goes for CDC is also a platform event. When you're a subscriber to them, you get them in chronological order. There's a guarantee that you'll receive those events in chronological order, which actually causes some issues sometimes because, for example, if a trigger is subscribed to a platform event, it can only receive a single string, like a stream. So it's a single processing. It's not parallel processing those. That'll come up later when we talk about scaling triggers that are attached to platform events, because normally in Salesforce, you have these parallel triggers that are running. I save something, a millisecond later, you save something. There are two trigger contexts going on at the same time. With platform events, if we flood that thing with 100,000, it's going to take them in chunks of 200. And it'll just go through them one by one. So there's some considerations when you're building like automation on top of it, which I'm definitely going to cover, but I just wanted to hit that now. It'll be like plant a seed, let it grow a little bit, and we'll talk about it later. So the big things to talk about with platform events and considerations when you're implementing this is to understand how the allocation works. So we kind of alluded to this. We talked about API limits. These are the actual limits for platform events themselves. So platform events, they have these three limits. There's a published limit, a delivered limit, and a subscriber limit. The publishing is like actual events that are published to the bus itself. That can happen internally with Salesforce. It can happen through APIs. It can happen kind of any way. And that limit is interesting because it's an hourly limit and it starts at 250K per hour, which is a lot, especially when you consider the delivery limit, which is when you actually have like a client, a Comet D client or gRPC that receives a message. That's your delivery limit. And it's a daily limit. It starts at 50,000. So then you're thinking to yourself, or any kind of like logical person would be like, well, with the general allocation there, I would never hit that limit because as I publish like 250,000, that's like 1/5 of that is going to get me over my daily delivery limit. And that's where we start talking about where these limits are consumed, because it just doesn't make any sense on the face of it. When I first looked at it, I flipped the table and I walked out. I stopped reading the documentation. I'm like, somebody is like on drugs. This makes no sense. So if we talk about this, I built like a whole diagram to discuss. If you look at this, the published limit can be anything that hits this. We'll talk about kind of exceptions. CDC doesn't count towards publishing limits. We can talk about that later. But you can see anything internally, including these APIs, can publish. But also triggers can subscribe. But triggers, they don't count towards any delivery limit. So if an event is delivered to a trigger, you don't have to worry about it. So that's kind of a cool thing. You're only worried for delivery about external clients. So that's something to keep in the back of your mind. If somebody's subscribing to Comet D, then you worry about delivery limits. If it's all internal with like, you're basically doing event-driven architecture within Salesforce, you don't have to worry about that delivery limit. You're only going to worry about publishing. Does this make sense so far? It's kind of strange. Is everybody kind of getting it?
We get it,
Yeah.
yes.
Okay,
Yeah.
sick. So that's publishing. And then the delivery is, you can see this, it's any kind of external system. And I specifically use this because if you have like two clients, so let's say you wanted to sort of have multiple subscribers within one system, they count individually and their deliveries count individually. So it's every delivered message. That can be kind of confusing. I have another diagram to kind of show the fan out and how that affects the limit. The other thing to consider is that when you're using this EMP API for a ARA component, for a Lightning component, it also counts against that delivery allocation. That's a little strange. And if you're thinking in your mind, like that's unfair, or it's not the right way to design it, or that's kind of ridiculous, and Astro is a crazy person for doing this, the reality is like, maybe yes, but there are like reasons why. And it's the whole Comet D thing and how our web browsers work. So does that make sense so far? It's like not the greatest thing, it's just good to know.
And that's for both Comet D and gRPC.
Yep.
Okay.
And there are no separate set of limits for gRPC. It just uses the same limit.
Okay. That does seem kind of like a bottleneck because 2,000 customers, 2,000 clients, 2,000 users is a fairly normal number in Salesforce. So I assume you're going to hit that later still, right?
I definitely, and like all the customers that I work with, like they have gigantic orgs. Like some it's like 50,000 users. One of them is like 125,000 users. So it's like it's like a joke. Like it's like, oh yeah, so the people on the like late night shift, they're actually going to destroy this thing. So
yeah, you need the reason this is cool because more numbers bigger than 2,000. Don't make me shut down this call.
And so the next thing is talking about how this fan out multiplies that number. So in delivery, so you're thinking if I publish one message, like that's one message is published, but then it also has to get fanned out and delivered. And for every receiver, and you can see here, it's every one of those lightning pages gets one of those messages. And then every subscriber from any of those systems in any combination, one message becomes 7 delivered messages. So that's really interesting. It's like really good to consider. And I have this conversation so many times where it's like, oh, I went through my allocations, right? And why did I do this? And we just walked through, well, it multiplies. Maybe you had like 5 messages that went through, but you have 10,000 or 1,000 subscribers, right? And then it just multiplies by how many clients are subscribed. And you can get to your limit very quickly. The first allocation per day for delivery is 50,000. And you can buy more to increase that limit by 100K each SKU. But if that 50,000 limit is really quick, like if you had like 2,000 subscribers, how fast is it? Like how many messages does it take? It happens really quickly. And like, especially if it's eventing architecture, there are a lot of events that are happening inside Salesforce. And it's like pretty easy to like hit 2,500. So is that making sense so far? The whole idea of how it multiplies that delivery limit per like how many people are subscribed?
So
Yep.
Pete,
Yeah.
we have a question from 50,000 users, concurrent or total registered?
Oh, so 2,000 concurrent subscribers is the limit. 50,000 is like the number of delivered messages. It's the first allocation. Does that answer the question?
2,000 subscribers, 2,000 listeners and then 50,000 events consumed by those listeners.
Yep.
So
that's
25
like-
events for 2,000 users or 50 events for 1,000 users and so on.
Yep.
So it's a daily limit?
It's a daily limit. Yep.
Oh, okay.
And then we're going to talk a little bit, once you buy the SKU, there's things that happen because that original allocation is 50K. It's a hard limit. But once you buy a SKU, it becomes a soft limit. And we're going to talk about that. I have a whole slide that talks about that part. And I just want to like start getting us warmed up with the concepts because then we can start like filtering in the actual numbers and how this works. So the next part is just talking about the subscriber limits. I think we've talked about this enough that I don't want to talk about it anymore, but that limit is 2,000. There's also a limit for the number of internal subscribers. So triggers or flows that are subscribed. That's also 2,000, but that's like 2,000 triggers. If you have that, you have bigger problems. I'll just be honest. So without the add-on SKU, so we're talking, we've talked about delivery limits and publishing limits. It's a daily limit for delivery per 24-hour period, and it's a rolling 24-hour period, is 50,000 per day, and that's where it starts. So that's without any kind of SKU, and the SKU's name is the high volume platform event SKU. So without any of those SKUs, it's 50,000. And the biggest thing to note here is that this will be like a hard limit. You hit this number, 50,000, the 50,000 at first you try to deliver throws an error message. Nobody gets anything. So that's really important to know. Tons of customers that hit that limit and go screaming into the night and punch me in the face. It's not nice. But it's important to consider when you're architecting this or thinking through it the first time. So once you add one of those high volume platform event SKUs, life gets a little bit better because the first one increases your delivery limit by 100,000. So that's nice. You got a little headroom. You doubled it, or I mean, you increased it by 200%. Now, the interesting thing here is it also becomes a soft limit. And this is interesting because when you look at like how you look after these usage limits, and this is where Tyson was talking about one of the things that we could work on is how you could see what your usage is. When you look at like the high volume platform event, once you get the SKU, it kind of looks like a monthly entitlement at that point. It doesn't look like a daily entitlement anymore. So you'll see that inside the docs as well. I don't want to talk about that too much. But the reality is once you buy one of these SKUs, it becomes a soft limit. So your limit's 150,000. You bought one SKU. That's awesome, right? But if you go to like 175,000 in one day, it's fine. It'll deliver the extra 25,000. There is like a hard limit eventually, and I think it's 5 times what your daily limit should be. Once you hit that, that's a hard limit, but there's a little buffer area just in case you have peaks. Whenever you're doing eventing, you're loading things inside of a Salesforce environment, like there will be peak traffic times, peak traffic days, end of the month, close of the quarter. There's always going to be that peak event. And so we do give like a little 5x buffer per day, just in case something happens. So that's also, as I don't know, whenever I'm thinking about building something new, I want to know what those limits are and where things are going to break ahead of time. I don't like phone calls. I don't like pager duty. I hate everything about it. Like cortisol should just be kept at bay. I don't want to, I don't know. I get punched in the face enough. I don't need extra cortisol through my veins, you know? So the idea is like, it's good to have these things in mind when you're starting to build or build the concepts of what you want to build. So big thing is, and it's my suggestion to anybody is if you're going to be using platform events in production, just buy one of these SKUs, and they're pretty inexpensive. I don't know what the cost actually is because I don't write contracts, but I know like it's very inexpensive.
They were quite reasonable.
Yeah. And it's like saves you heartache just having that soft limit.
Now, having architects not have to worry about hitting hard limits early is worth the time.
Mm-hmm.
A lot of Rogaine treatments from me. So
I'll say too, so we encounter this a lot where customers don't have this and they hit the limits, whether it's because of Black Friday or any of those big spikes. If you call your Salesforce AE, there's actually not a quick fix to this. So it's not like, oh, we'll call the AE, we'll buy an order form, and then it'll automatically bump up immediately. You're probably looking at a couple of days before you get these allocations, and then you're back to normal. So that's part of the warning that we say. It's not just that, okay, now I know that I need to buy a SKU. If I hit the limit, you'll need to factor in, you're probably going to do plus or minus 2 days before this kicks in.
Yep. Because our backend provisioning process, another piece of trivia, is actually like a 24-hour batch job. So if you buy something from Salesforce, it can take up to whenever you hit that 24-hour batch job to provision it. So that's a really good point. It's better like prevention. What do they say? Like an ounce of prevention is worth a pound of cure. Mm-hmm. Not talking about vaccine cloud again. I don't know if anybody felt that coming, but no, I'm not going to talk about it.
Pete.
But the idea is that like you can definitely like save yourself a lot of heartache. Just one of the SKUs is very inexpensive, and can save a lot of heartache. So I think Rao, you have your hand up.
I'm sorry, I got the question answered. Don't worry.
Oh, perfect. I just want to make sure.
So one thing I'll just say, sorry, Pete. So it's not always that you're going to hit this limit. If you're managing orgs that are smaller users, smaller events, you could probably get away with this. But the moment you're hitting, I'm using Salesforce every day across X number of users and they live and breathe, and then or there's a lot of automations and we're dependent on Salesforce, you're more than likely going to hit this limit.
Mm-hmm. Yeah. I always just recommend it. And maybe it's just because I like live in like this battle place where people are hitting me. But the idea is like when you hit that limit, it's really not a great day. It's not a great day. And people just scream for no reason. You know, business users, like they want things done. They don't understand technology. And why did this break? better not to have those conversations. So the next thing, the two exceptions to all of these limits. First of all, I think I talked about change data capture doesn't affect your publishing limit, which is good to know. So if you turn on change data capture and you're not like using it for anything, it won't break that publishing limit. It's not going to get you to 250,000 in an hour and then just say like, you have to stop publishing. So that's really good to know. And the reason we do that is because it's really hard to guess how much is going to be published, right? How many like things are going to be saved, updated, created, whatever. It's really hard for like a customer to guess that ahead of time. So we don't make it affect that publishing limit. So that's change data capture. Real-time event monitoring is another place where platform events are used, and you subscribe the same way using Comet D or gRPC. And this is an interesting one because it doesn't apply to your publishing limit or your delivery limit. Kind of amazing. That one customer it's like 125,000 users. They turned on real-time event monitoring and they did like 120 million deliveries in a day. And the PMs were like, yo, like our production people are like, hey, this house is burning down. 120 million deliveries. It's interesting, and it just doesn't count towards their limits. So they didn't have to buy any SKUs. We just had to figure it out internally that we could deliver that stuff. Does that make sense so far? Is this good info?
Yeah, I didn't know real-time event monitoring was part of platform events. So
Yep.
that at least is net new knowledge.
Yep. And these are all like kind of deep cuts that I have in this. Things that came up like a couple of times, and it's kind of obscure stuff, but I think it's good to know. The next part of this is all about change data capture. We talked a little bit about what it is, but this is sort of like a deep dive into some cool features that exist inside of change data capture. First of all it does is it streams the changes to a Salesforce object. You turn it on for account, and it's going to tell you if an account was created, if a field was updated, if something was deleted, if a field was removed, any kind of change, it's going to capture that. And that's why it has that really original name, change data capture. It works just like a lot of other CDC systems out there, like SQL Server has this, Oracle has this, everybody kind of has this if you have a database. So it's really helpful. It's a huge thing to use for like syncing databases together. And there are also other fringe use cases. For example, there's a concept called asynchronous triggers. You have a trigger context that exists and you're running, but what if you didn't need to process something right away? What you normally would do is like at future, queuable context, these kind of things to push it to that next like DML context. But instead, what you could do is you could have a trigger that's subscribed to that change event off of account or off of opportunity. So you can actually have this secondary trigger that gets triggered. It's a very cool architecture, and it's something I have like some diagrams for, but it's called asynchronous triggers. And people use it a lot. It's been helpful for like a ton of customers, especially when you need to start scaling those triggers and users hit a save button, it takes 3 minutes to save. Not a great experience. So,
Okay, so why would you do that? What was a use case for your change event would fire an event and then a trigger would be listening for that event on it? You lost me a little bit.
Oh, so here's a good way for this. So if you're like creating an opportunity and there's like a lot of opportunity setup that happens in the opportunity trigger. So you create a new opportunity and there's a ton of child objects that need to be created, links that need to be made between different objects, all sorts of stuff that needs to happen and checks. Sometimes it's not reasonable to have like the user sit through that because they don't need that information right away. And so what you do is you kick it off asynchronously, and then, oh, my opportunity was created. They move along, and then all of those other things happen asynchronously.
Okay, you're pushing your queue someplace else instead of, but okay, gotcha.
And the other thing is queuable, and this might be for that platform developer 1 exam, something to know about queuable and about at future, is we don't provide an SLA on how long it takes. We always say it's going to be something kind of right after that DML happens, but sometimes that our queue depth goes pretty deep on like Black Friday or other times that pod that you're sitting on is busy. So it can take 3 hours. We had one customer where it took a day and a half for like that at future to kick off. So important to know that there's no SLA on that. And so with this, you don't actually have a delay. It kicks off immediately when the platform event is published. Good stuff to know.
Gotcha. Yeah, thank you. No, that's okay. Yeah, keep going. My brain is busy breaking.
This is a lot. This is a lot. This is a fire hose for sure. This is just, and I apologize, this is like kind of my personality, maybe it's a flaw, but it's just like all this information. We can share all these decks with you, and then also it's being recorded. Yep. And so this is like a kind of a picture of what that looks like, where something changes and CDC automatically like sends that change. I think we kind of talked about this at length, but it's just a picture of how it looks. You have like that change event gets passed to platform events, and then Comet D or gRPC can deliver that to subscribers. So this I'm not going to go into because it would be way too much, but there are different types of events that happen for good reasons. Like if you're doing a huge update, Tyson talked about this. Like, let's say you loaded 1 million records into Salesforce. CDC is not going to publish 1 million changes. Like, that's just insane. And I talked to the guy who built Change Data Capture, and the original idea was you want to sync databases, but eventually you do have to kind of audit them and make sure that something wasn't missed. And at this point, if you're loading 1 million here, it's probably a good idea just to load the 1 million in that other database that needs to be kept in sync. Instead of actually trying to stream those changes down, you just copy those databases to each other. And that's kind of how it was built. So you have these different type of events where it's like normal is just that change event. A gap event, this is where like there's errors or something that happens during like a DML context or something like that, and it'll say there's a gap. And then overflow is when you hit that over 100K. All the definitions are here. And you can look at this. I don't want to go too deeply into it because I know we've talked about a lot so far. And I have it all spelled out in great detail. Here's another thing that's very cool with CDC. It can also be used for platform events. So let's say you want to subscribe to this, but you have like 5 change events that you want to subscribe to. But you don't want to subscribe like individually. You don't want like a separate computer to have to subscribe to 5 different feeds. You can do you can create something called a channel. And the channel actually takes all those events and amalgamates it to a single subscription point. So you could say, and I think the example we have here is I have an account, a contact, and opportunity change events. I'm just going to make it sales events, and that'll be my channel. I subscribe to that, and then everything for sales is going to be delivered to those other systems. And it's sort of like, I don't know if you've used like permission set groups. The idea that you could just group all those permission sets together. It's almost like a profile, but you can just group them together and then you can apply them that way. It's just an easier way to manage it. Does that make sense? This is a cool thing. I don't think a lot of people know
Yeah, it's a new concept, but I get it.
Yeah, it's really cool. And one of the interesting things is these custom event channels, you can also say, I want to like make sure every time an event goes out, I need to have like another field that goes with it every time. Even if that field didn't change, I need like a foreign key to go with it. I need like some field that identifies that row. You can actually, and it's called enrichment, you can enrich those events so that every time it goes out, it has like 5 or 10 or 20 fields that go with it every time. And that's also really important. Sometimes when you're building the CDC system, you're like, well, I need this foreign key, but it didn't change, so it didn't send it to me in the message. When you're using channels, you can actually add field enrichment to that channel. So it'll add those fields every time that there is a new message out. Does that make sense?
It does. Everybody, I'm answering for everybody, just so you have a voice on the other end of that question.
Yeah.
The only thing I'm starting to get scared of is all of the OLTP processing you're putting on top of my ephemeral Kafka system. How and where are you managing that extra transactional load and still keeping with Kafka's greasy scalability?
So is the question like, there's a lot of extra things that are happening here to like enrich events and amalgamate them, do these things, and then how are we handling it internally?
Well, yeah, and this is where I started to love Abigail. When she smacked me down, I was asking questions based on how I've dealt with Kafka before. And Kafka is not something where you put highly sensitive, has to be transacted data, has to be sure that it gets somewhere. It's more about possible scalability and 98% accuracy. There's going to be stuff that falls through the cracks. But apparently all of this extra logic and security, she was like, yeah, no, it's logged. There is a record of it somewhere. You don't just lose it in the ether like you do with regular Kafka. there's apparently some more, a nice candy shell around the dumb way that Kafka works, but that candy shell has to come with some performance penalties.
Yeah, so yeah, it's important to note that Kafka was originally built for LinkedIn, and it was like a B2C thing. And it's like, hey, if you get your notifications, that's great. If you miss one or two, it's not going to like end the world. And then in the world of like enterprise space, like you want those receipts. You want to know that everything got there because like there's a business process and you have promises and things like that. To answer your question, like very bluntly, which is just who I am, is like there are it's a possibility that a message will get lost because we are using Kafka, and this is built in more of like a defensive programming paradigm than those receipts. It's not like a service-oriented architecture type thing where you have all those receipts going back and forth and like my envelope got there and I get the thing. Did you get it? I got it. Are you sure? Yes, I'm sure. You don't have like those kind of checks happening all the time. So there is a possibility something gets lost, but it is always logged in our systems, and we have some fail safes in the back, just because we've dealt with this at scale for a long time now. So we do clean up some of the things that Kafka misses. The other thing is that it's not going directly from like one Kafka topic directly to these subscribers. We have like a whole architecture built around this to make sure that you get, like, for example, chronological delivery. Like we keep that for you. Flow control. We're actually managing that in the back end with our different topic streams and the way that we've architected the back end. I don't want to talk too much, and I don't know exactly how much I'm allowed to talk about because some of this is like proprietary knowledge, but there is a lot of extra stuff in the background that we do, sort of a secret sauce. And we have like some pretty incredible zookeeper people.
Okay.
Is that helpful?
Yeah.
And then Rao, you have your hand up.
Yeah, like two questions. Like, for example, I'm from Oracle background. Oracle, they have a standard we call business events. Like they raise the business event, right? For change in record, like, create a record and all. The payload, the Oracle gives the payload is only the primary key. Then you have to write your payload, like, what information your subscriber wants. Okay. So here in Salesforce, like you might have standard events, right? Like, what you call account created or opportunity created kind of thing. So what kind of payload that it generates? Do we need to customize that?
So the payload itself, I actually, funny enough, I have like these example payloads. It's going to just send like the fields that have changed, what happened, the entity name, its commit numbers, or other things to keep track of what's going on. You have like the origin that it came from, like what internal API is using, whatever. There's a transaction key for each thing, and that's how we log it in the back end. But then we also have like what it changed to. So all those things come through. So you can see the fax changed, and here's like the fax number. So we have all that stuff in there. We also, this is about that enrichment. You can actually have fields that go every time, even if they haven't changed. So we do send a full payload. It's not like a park and retrieve, I think is sometimes how people explain that, where it's like, hey, I've got something for you, and then you have to come and get it. We just send it to you.
I'm talking about like, suppose I create a new record into an object, right? Like, we don't know the subscriber, what information he wants. Then you have to give entire payload to them. Hey, whatever you want, you just grab it from that payload, right?
Oh, yeah.
Yeah.
So,
second question is like, when you combined 3 different events into a channel, let's say like, account, opportunity, account, contact, and opportunity. So when you combine in the channel, they go as a 3 different messages, or a single payload consists of all the information from the 3.
No, those will be separate payloads for sure. And then it tells you what entity it is.
Right,
so
right.
You can do it in the back end. So actually, to answer your first question is, that is a consideration. What if you have 800 fields on opportunity? You just create an opportunity and every one of those fields changes. Not that anybody would be that crazy to have 800 fields, but like that's 800 fields that it's going to send to you. That's insane. We actually like, it's something that's been in, I think beta for a while. It's going to be GA in winter, is something called filtering. I haven't created a slide for it yet, but it's a big feature. It's the idea that you can actually filter those events. So you don't just get that deluge.
Okay, that's good.
Yeah.
Thank you.
Is that helpful? Good.
Yep.
So it's a lot. It's a lot. So like the last part of this is like, and I have 2 more parts. The one is like, how do you monitor your usage? It's kind of a strange thing here, and we talked a little bit about how it could be better. There are a few ways of doing that. And then I'm going to talk about the actual use cases and some really cool like dev stuff at the end. So not just like, you know, like pie in the sky stuff, but actually how people have used this. So the monitoring stuff, 3 different ways that you can do this. Inside of the Salesforce UI, you can see your delivery number. It updates daily. So this number is updated daily. You can just find it inside of company information and it's under usage. There it is. That's deliveries. The next way that you can do this is by querying. So we actually write something to our database so you can SOQL. And these are these different objects. And I think in here I have an example. It's platform event usage metric is the object name, standard object. You can pull it from there. So that means you can like report on it. You can pull it through our APIs. You can do whatever you want there. It's another thing that's updated daily. And so you can just go into like developer console, like that query. I can't remember what it's called, like SQL Explorer or something like that, and just write your query in there and get the answer. That's for change data capture as well as platform events. The other way is using the limits API. I don't know if anybody's ever called a REST API for limits. It's sitting inside of that API as well. So you call for the limits. Among all the limits will come your platform event usage limits. There's some information in here about if you have a SKU, if you don't have the SKU. And that's something, if you're really interested in this, you can go through and see what those different breakdowns are. But the idea is that if you have that original allocation, 50,000, it's a hard limit, that gets updated faster in our usage. If you have the one SKU, if you bought one SKU or more, it's really considered your usage is like a retroactive look to see if like you're going over your limit too much, because we give you that buffer area. And then we can talk to your account executive and kind of true up if you need to. So it's kind of considered more of a retroactive thing. As we learn more and more about how things get broken and people come and punch me, we realize like maybe we should make that a little bit easier to read. And so this whole monitoring piece, we would love feedback on it. If anybody has been doing this and run into problems like trying to figure something out, there are a lot of like metrics that aren't captured in here. One of the biggest ones is what user is subscribed and who's receiving what. Other things will be, we talked about queue depth. So the idea that like, if you're using flow control, you're doing like 10 records at a time, but there's like 100,000 records per hour that are getting published. You're never going to catch up. That means your queue depth is increasing faster than you're able to consume it, right? There's no way of finding that out right now, unless you call up Salesforce support and they run a query in our Splunk. Otherwise, there's no way of finding out. So that's another thing. Does that all make sense? Is this like too much? Is this interesting? We're still interested? Okay.
Yeah, that's good.
Okay, cool. There's also, if you wanted to, the publish status event channel is another thing where you can actually double check that something got published. So we were talking about kind of the lossy nature of Kafka, where you're like at like maybe 3 nines or 4 nines of like reliability here for how many messages will get published and will get delivered. Here you can actually subscribe to this and it'll tell you whether things got published or not. If there were any errors, what they were. And this is when we said there's a log for things that didn't happen right. This is your log for things that didn't happen right. So that's to Abigail's point. It's logged somewhere. It doesn't go into the ether. Streaming API is a lot of the same stuff. You just can't use gRPC. I have to fix my slide. Has anybody ever used streaming API? Anybody in the audience?
Not by hand.
Yeah, it's an interesting thing. It's used in a lot of tutorials, old school. Yep.
Yeah, online we have a yes.
Oh, good.
JJ
Good.
did. Yeah.
Okay, so JJ did. And streaming API is interesting. So we've talked about like all of these like platform events and change data capture. You have this event that you're subscribing to. With streaming API, you actually subscribe to what's called a push topic, and it's defined by a query. So you could say like, you have a query and it's like, any close one opportunity, I want to get this message. And so your push topic might be close one opportunities. You could subscribe to that and you get all those things. It has filtering built in, but then there's like this big, huge, like incredible caveat that it has like a hard limit at 1 million per day. And you can't pay anybody at Salesforce as much as we would love to have the money. You can't pay anybody to increase that limit. So we've had some really interesting conversations there, again, where I have to get some band-aids. So here's like a very detailed look into this. You can have this this presentation at the end and take a look at that if you're ever interested. And I have that here. Streaming API has a maximum of 1 million. It cannot be increased by adding any of these SKUs or bribing anybody or I don't know, saying nice things to Astro. Cannot be increased. And then I have some stuff on how you monitor it. So this is the good part. So we got through all of like this is like, I feel like it's almost like a college class. It's a good thing you're at a university. So we have like scaling platform events and streaming API, huge topic. We talked about it a little bit before on front-end notifications. We talked a little bit about triggers, but here are like some diagrams to show you how that works. The first thing is that you can imagine as you like increase the number of systems that are going to be subscribing to these events, each time you increase one, it multiplies by one more. So if you have like 7 systems, or what is this? Yeah, 7. You're multiplying by 7 every time you publish something. So maybe that doesn't work for you and like your allocations are crazy. You have a crazy amount of change, or it's just like you don't want to pay for any SKUs. And I could do this in a more simple way. So what you can do is you can put middleware between it. So that middleware is the one subscriber. So every message that's published is delivered once. 1-to-1 is kind of nice. No multiplication. And then you can use that to dump into a Kafka, an actual Kafka that can handle your system fan out. So that's like definitely a best practice. If you have change data capture as a huge enterprise, you can even just go directly, like have a little node app that's sitting here as middleware, and it'll just publish directly to Kafka for you. It's definitely a best practice. Does that make sense?
MuleSoft has its own internal message queue system. Is that another viable handoff that could stream events?
Yeah, they call it
MuleSoft?
Anypoint MQ.
Yeah.
Yep, it has its own, and it's definitely viable. The other thing you could also, instead of it going into Kafka, you just deliver it directly because it is a real-time system. But sometimes customers like this, and it's kind of the eventing paradigm. The idea that like I don't need to know anything about that other system. I don't even need to know that it's subscribed really. I just publish events there and it can use them how they want. Anypoint MQ, it doesn't have like that same connection. Like you can't just like use that Kafka consumer, right? That's just like every language has it. There's a little bit more work to be done on that. Sometimes customers use Anypoint MQ and they love it. I'm kind of agnostic. I just use whatever works. I know Kafka a lot better than I know Anypoint MQ. So that's why I put it in the slide. And they might actually hate me for that, the MuleSoft people, but it's just, I don't know. It's just what I did. Time is not infinite, right? So that's a best practice, scaling this for notifications to your backend systems to the enterprise. The next thing is front-end notifications. This is a huge one. As we were saying before, you have that 2,000 subscriber limit. You're also multiplying by however many people are going to be like subscribed to this on a front end. It's a crazy way to try to figure out how many SKUs you should buy and all sorts of other things. You run into a lot of problems very quickly. So you can actually do similar to what I was showing before, where you have that one subscriber and it's like kind of a single tenant system over here. And then it uses a WebSocket server to fan out. So in the front end, you're just subscribing to this WebSocket service and you can receive those notifications in real time. So does that make sense so far? That part of that architecture? And then the next part is interesting. And I don't want to like bring in too many topics into this, but big objects is like a big data store that's really, really cheap on Salesforce. If you wanted to persist those messages, like you have notifications that are useful for somebody to stay around, you could actually like have those persisted in big objects and have like a cleanup job every day. So you could have some persisted messages in there. So they load the page, they get the notifications that they just had. Like if their browser refreshes and they miss the notifications, it's a huge, huge problem. But it's a very like inexpensive and easily scalable way to do that. So that's definitely a best practice. We use this for retail banking. When people are like, a banker is sitting there and they have people that have made like an appointment to come and see their banker. And they want to know as they're like looking at their computer, if somebody shows up or if they're running late, something like that. They'll get notifications on Salesforce saying, hey, your next appointment showed up, stuff like that. Does that make sense? It's kind of an interesting use case. We also have customers that use it for multi-org notifications so that they can funnel everything through one bus and handle it centrally, and they can also cross share. That one might be like a little crazier, but it's actually a really cool architecture. The idea that you could just bring all your notifications to a single stream, you can monitor it, you can actually log them, and then you can manage that service centrally. Some customers have like 40 orgs, some have like over 100. So this becomes like a very useful architecture.
I'll just add, so if you are supporting highly regulated industries that use Salesforce, this one is critical.
Yep.
For just for governance itself.
Yep. And you might have SLAs that you need to make sure if somebody comes back and screams, hey, like we did deliver this, it showed up, here's the log of it. And also because the industry I work with is like financial services, is highly regulated. And that's why we kept everything just IDs. You can see like an example notification here. It's IDs, Salesforce knows what they are, but like no external system needs to know anything about it. We kept it very clandestine. Does that make sense? Pretty interesting architecture stuff.
Yeah, no, we've left dev and gone to multi-cloud architecture, enterprise scale. It's fantastic. I'm drooling.
Nice. Now this is where we get back in a little bit like deeper into like the dev. It is still scaling, it's still enterprise architecture, but it's really relevant to developers who are like writing triggers if you wanted to write a change event trigger. So first of all, we talked about asynchronous triggers. This is a kind of a diagram of how that would work. It might just be like you're using change data capture or you're using platform events for this, but that you would have some sort of CRUD that happens, record CRUD, and that kicks off your DML context. After it's committed to the database, then that change event gets published. And it's a completely different context. It's a separate trigger context. So that can be helpful. You can see up here, synchronous, user waits for the result. Asynchronous, they don't have to wait. It can also just be with platform events. It happens once that's you're in a trigger or any kind of context you want, then it goes to this asynchronous context on that platform event. So the really interesting thing is this. So I talked about how it's your guaranteed chronological delivery, which is a very big sticking point, because if you have so many, like, let's pretend that your trigger can do 100 per 30 seconds, right? If you're getting 200 or 500 or 1,000 per 3 seconds, it's never going to catch up. The trigger won't be able to actually consume those events fast enough, and you get your queue depth kind of blowing up. And I keep saying this because it's happened like 100 times with customers of mine. So we worked with an internal team. I don't know if anybody's ever worked with our critical account teams. It's called the CAT team. They're like 6 of the craziest, like deep knowledge people in Salesforce history. They know everything and all like every little kind of hidden thing. We work together to try to figure out an architecture for this. How do you scale it correctly? And this is kind of what we came up with, is that you would have several platform events and you just distribute the load. It's sort of like load balancing. You use the platform events to do load balancing. And you can use the same trigger handler. All the code is the same. It's just that each one of those triggers is to a different platform event. For this example, it's really that an external system does that load balancing. That was one example that a customer of mine did. Another one is that you have a custom REST API. So Salesforce does that load balancing, and it's all API driven. And so that's interesting. The next way is using a dispatcher. I don't know if anybody knows dispatch patterns, but using a dispatcher platform event. And its sole purpose is to do that load balancing. So that can come from anywhere. You can have triggers, flows, processes, Apex, could be anything from the API, anything that delivers to that bus, this dispatcher platform event, then we'll get load balanced across all those different things. And you can see here, I've had customers that needed 15 triggers because they're just like, I don't know what they're trying to do and what they're trying to fill in there, but it's definitely not a garden hose. They just want so much data and so much processing that they needed 15 of these, but it kind of will scale to whatever you need. And like there are limits to the number of platform events you can have. We don't have to get into that, but it's like this architecture works the best. There are other ways of doing it. You might see online of creating like these hashes and actually having several triggers subscribed to one platform event. there are issues there with how our backend systems work, and it's like undue load on our systems. So that's why we came up with this architecture. Anyway, these are all like, you don't have to remember any of it because we have these pictures, but it's a thing to consider that when you're subscribing, you might need to scale this up. Good so far. So the last thing, this one is super interesting. I came up with this like for one Dreamforce because we were doing a bunch of call outs. But I don't know if anybody's familiar with, once you're inside of a trigger context, you can't do a call out. And then once you're inside of like a future context, you can't call another future context. So once you start thinking about this, like if I'm in the future and it hits a trigger context, I can't call the future to go do my call out. You get caught in this thing where like a trigger can't do any kind of like call out to an external system. So you get caught here. What I decided was this, like, what if you just had a platform event that handled your call outs so that you would never be in the future trying to call the future? You would always know that you're just going one future in the future. Oh man, that's confusing. One future in the future. But it's a bizarre thing that you run into with that the callouts from a trigger, that you have to go to a future queuable and you might be in the future already. And if you are, it's not fun. You have like kind of your hands are tied. There's nothing you can do. But if every call out actually goes through a platform event, you can rest assured that you can always call it the future or do queuable. And that's the end. There are partner integrations. We have like an integration with EventBridge. And I don't know if anybody does AWS development, has AWS inside their stack, but that event relay thing is pretty amazing. It'll automatically publish our platform events to EventBridge in AWS. But that is my whole thing.
And
Thanks for
that's
bearing
with
with
who? What was that? You said
it's AWS EventBridge.
Oh, Amazon. Okay.
Yeah.
EventBridge.
Yep. Amazon Web Services.
Cool.
So that's it. We made the end.
Whew. Well, and then Abigail, are you ready to go next?
I'm just I think I'm just Vanna Whiting tonight.
Oh,
So
that's
was
amazing.
this
Yeah, my head's exploding.
Just wanted to ask, was this useful? And are you going to invite us again soon, or we're never invited to your user group ever again?
No, I think we're going to become the Abigail user group. I think you could probably provide us with information for the next couple of years at this rate.
I think it's going to take me a couple of years to figure out what he said today.
So, and I actually used that last pattern. That was one of the hacks that I found that I've been sharing to get Flow to do infinite records.
Yep.
I have an event, or I have a trigger, a schedule, create an event triggered Flow, and if the Flow can get through all the records, it ends. If it can't get through all the records, it marks its place and admits another event that calls it again and has it trigger some more. So that's, love it.
Recursion is good. It's good. Raul, you have a question?
Yeah, this is a beautiful presentation, but like too much to like, chew this stuff. I guess we need supporting lectures or something like that, like for each concept, how it is resolved, what is the use case kind of thing, so that we can understand properly.
Sure.
Yeah, this is great. Well, cool. Yeah, no, thank you again, Abigail and Peter and Tyson for us as well. This is fantastic. I don't know if you want to, it's a little late, but I could listen to this stuff all night.
We're pretty close to the end. Are there any questions?
Questions? Everybody drinking from the fire hose here? Yeah, this is next level. This is where, data and Flow are you have scalable options. I always knew there were hacks out there that we could figure out how to connect to things. If we had, if we were one of those 5 or 6 clients, it could probably get done.
Mm-hmm.
It's real systems underneath there, but this is bringing that heavy scale to to the masses. Bill, you have a question?
Yeah, I still have my question about that thousands per minute event. How do you handle that in Salesforce side? How do you batch that?
Batch what?
So-
What type of events?
So the example when we started, you have 75K events, I assume, per minute, and it's batched in Salesforce side.
Yeah.
So you have a trigger based on those events, and that trigger is batched, or how exactly that batch happened?
So that goes back to this where like 75,000 per minute, and maybe your trigger can't handle that. Like the trigger won't be able to get through that queue fast enough. They're being created faster than the trigger can actually process them. And then what you need to do, since the trigger is just single threaded, it just takes like a single chunk at a time because the guaranteed chronological delivery. You have to do something to make it parallel. And that's where these architectures come into play, where you have multiple platform events that you fan out to. Basically, the idea is that you're publishing to these different events so that you have different triggers running at the same time. So if you have 75,000 per minute, it's hitting like all these different triggers at the same time, and it can be handled in a manageable way. You'll eventually get through it.
So yeah, and that makes sense. So even there will be like thousands events per second with this pattern, potentially I can handle that.
And the interesting thing here is, so you have 75,000 that you're getting. Maybe your trigger is handling them 1,000 at a time. You can actually set how many records will come into the trigger at any one time. It starts at 1,000. You can bring it down to whatever you want. The interesting thing here is that it would be individual people saying, I want this thing, right? Like I'm signing up for this thing. It'll hit the trigger in a batch, and the trigger can actually do a bulk load. So it can do like 1,000 at a time, which is faster for Salesforce to process than getting individual like database transactions. Does that make sense?
Yes.
It's sort of like bulkifying,
Yeah,
real-time stuff.
yeah, that makes sense. So yeah, that answered my question, because I was surprised how, even with event, how do you handle that? Because each DML you can only do 15,000 records or 10,000.
Yeah. And like, yeah, each batch would be like maybe 10K or like 2,000 for REST API. There are those limits, and you have like, maybe there's some like bulk API, it stops at about 150 million per day. That's also an interesting limit to know about. 150 million is like your total daily allowance for bulk API rows. Sometimes customers go above that. With platform events, you can far exceed that. So it's another interesting thing to know.
Thanks. Another question is the new GPRC or G. It's subscribing. It's pulling instead of pushing. I'm looking at the documentation. It's saying.
Yeah.
So that still consume your delivery allocation.
Yep.
Okay. So even I query that, I still consider that as a delivery.
Yeah, because it's not like a query necessarily. It's like saying that I'm ready for the next batch.
Okay.
Yeah.
So the change is mainly on the format, how to get the event data.
Yep.
The
Exactly.
limit is still the same.
Yeah, and like the protocol is different, like how it works.
Internet just went away. It's funny, it's almost always at 8:30.
Are we good?
Oh, we're back, yeah.
I think that's it.
Yeah, our internet
all we
dropped.
got.
Oh, okay.
Thank
Yeah,
you.
well-
Can you hear us again, Peter?
Yes.
Okay.
But it's fine. Bill had some questions and we're answering them. Worked out well. So anything else? I'm on the East Coast. It's almost 9:30.
Yeah, I think that's all the content we have for today.
That's great. Okay. Yeah, no, I think we've actually hit everybody's sleep timer here. So we did finally lose some people, but Peter, they were going strong. You still had like 85% audience all the way up until about 10 minutes ago.
Okay. That's
So
good.
thank you for sharing all of your broken noses.
It's nice, right? They got to be good for something.
Yeah,
My
that's
doctor's
a
happy about it.
demotivator. It's like, it may be that your purpose in life, your only purpose in life is to serve as a warning to others.
Exactly. And it's funny that I was doing this with Tyson, like Mike Tyson. You don't know what your plan is until you get punched in the face, right?
Oh,
But it's good.
outstanding.
Yep.
On
So,
that note,
yep.
yeah, sorry, go ahead, Pete.
No,
So
go ahead.
what we'll do, so we have slides from Tyson and from Pete. So Paul, I'll send that over to you, and then if we want to publish that to the user group,
That'd be great.
that'd be awesome.
Thank you again,
Awesome.
Abigail and Peter. I
Oh, you're
appreciate
very
your time.
welcome.
And thanks so much. Thanks everybody for joining. Good night. And
Thanks
we'll
for
talk to you
having
next
us.
month.